Hello, my lovely friends. Yeah, welcome to my home, indirectly. So the last several videos have kind of been on a logistic regression kick and invented a bunch of plots. And now I'm actually going to try them and see how well they work. So I've got a data set I haven't hardly even looked at. It is, I'll leave information in the description about it. Okay, so it looks like it's some sort of marketing campaign where they're trying to figure out, or they're trying to recruit people to use their bank. So it looks like the outcome variable is if they made a sale, basically, and it is called Y in this data set. That's quite convenient. And so I don't really care about this data set. I don't really care about this marketing campaign. I just want to use the tools. All right, so all I've done is read in the data set. I'm going to require flexplot. And then require tidyverse. And so I've got a data set with a single outcome and a bunch of predictor variables. And again, I'm just trying to test this. So head D, see what variables I'm looking at. Age, job, marital status, education. Default, whether they've defaulted on a loan before, I think. But really the outcome is Y. And so I'm going to just do a random forest just to figure out which variables are most important, because I really just want to look at variables that are predictive. So I'm going to go require party, because that's going to give me the cforest function. So do preliminary variable filtering. So I just want to find the variables that are most predictive. In this case, I don't care about finding the quote-unquote correct model. I just want to see how well the plots are working. But I guess it might be more advantageous to pretend that I do care and really put the plots to the test, so maybe I'll do that. Anyway, so rf underscore mod equals cforest, outcome is y tilde dot is the shortcut, data equals d. Okay, let me give you an update. So we've got a data set, bank. It is stored as a CSV file, and CSV stands for comma separated value. And yet the authors decided to separate values with a semicolon. What were you thinking? Took me a bit to figure that out. And then strings as factors, because the cforest function doesn't like strings. They have to all be factors. And I've tried running this multiple times, but for some reason the random forest is having an issue with a 4,000 observation data set. So I'm just sampling 500 because I'm really just using the random forest to filter things so I can figure out which variables are most predictive. P outcome. Ooh. What is P outcome? Outcome of the previous marketing campaign. And month. Last contact month of year. It's categorical. So apparently certain times is better to contact people than other times. Duration is last contact duration in seconds. So they are pestering these people, man. Just pestering them. And then housing. Do they have a housing loan? Contact communication type, telephone, cellular, or unknown. Anything beyond age we're not going to worry about. Now that I know what the most predictive variables are, I want to just kind of start visualizing these using my new tools. Let's look at the best variables, shall we? And the top one is the P outcome. So I get to use my magnet plot for the first time. Yay! So I'm going to go magnet plot, and I'll go y tilde p outcome, data equals d. P outcome, let's look at what that is again. Outcome of the previous marketing campaign. Oh man, I love these plots. All right, so these are previous marketing campaigns. They're paying attention to what these people said before. And the y-axis is, did they make the sale this time? And so, not surprisingly, those people that they've sold products to before, they have the most success. So out of those 129 people, like over 65% of them-ish decided to buy something else. And other than that, we've got like 20%, and then like 12%, and then like 10%. Seems like those are pretty good returns. And you know what's interesting is I was interpreting this plot without even thinking about it, which is really cool. Like, I'm not sitting here struggling to see what's going on, and I'm not patting myself on the back about how amazing this plot is because it's just working as it should, which is, now I'm going to congratulate myself. One problem that I am seeing, though, is that like this sample size is so overpowering that it makes it harder to compare, but I don't know that you can do much about that. Because, yeah, I mean, look at that. So you've got, like, clearly much less density over here than you do over here. So in some ways, this is misleading because ideally, what you can do is compare the heights, but you can't compare the heights. You have to compare the heights and the densities. But if we go dot size equals 0.5, I think then that will work. Maybe better, but you're still comparing densities. Yeah, and I think shrinking the dot size isn't going to help. Okay, yeah, that wasn't a good idea. That wasn't going to help at all. But that's okay. And you do have the actual sample size listed on the plot, so it's okay. What's interesting is that it's saying that if we knew you were a failure last time, you still have a better probability if we didn't know the outcome of the last marketing campaign. I wonder if that 3705 represents... Was everybody called twice? And if unknown is really should be labeled like first time call, but probably not. I mean, you would think they would track that sort of thing. So I don't know why there's an unknown in here. Like, it's not surprising at all that that's the top predictor because, I mean, look at how predictive it is. Like, vast differences between the different conditions. Last contact duration. So how long did their phone call last with them last time? So let's go duration, except we're not going to use a magnet plot. We're going to use a logistic overlay. Still don't know what to call that. If you have any ideas, let me know. That's interesting. Okay, this is actually accidentally informative. I'm looking at this and saying, why is there a dot right there and nothing in between? And I'm thinking, oh, duration is probably like super skewed. And if I go flexplot duration tilde1, data equals D. Yep, sure enough, that's exactly what's happening. Now, if I look at this, I don't think that's a very good fit of the model. So the logistic overlay is actually kind of doing its job because, like, it's biased. So if you kind of follow the trajectory of these dots, I would think the logistic should kind of do a curve. I wonder what would happen if we modeled a polynomial for that? Because normally if you're doing like a linear regression, and there's some curvilinearity, the first thing that I try to do is I try to fit a polynomial, or the other alternative is to do a transformation. That would probably be a better thing. So instead of modeling duration, you model the log of duration. Let me try that first. So duration equals log of duration. And very often a log will kind of linearize something that is looking like that. Let's look at, oh, distribution looks beautiful. I mean, it's a little negatively skewed, but it's not like crazy like it was before. Now, if I do that plot, that fixed it. But, except for this data point right here. But I don't think I'm too worried about that. But what I'm excited about is that this is exactly what I want to happen. Like, I used the logistic overlay plot, saw from the plot that there was something wrong with the model, and then I fixed the model, and now the model works. That's what I want. Actually, I'll call this duration log. I am interested to see what would happen if I modeled duration as a polynomial. Okay, I'm going to add that to my list. Add to list. Allow logistic overlay to show polynomials. That was cool. That's a success that we looked at the plots and it said, hey, I don't think this linear version is going to work very well. All right, that's cool. So we covered duration. All right, and then we looked at P outcome, which I am like giddy that works so well. Okay, so now we can do P days. So D $ P days. What is that again? Number of days that passed by after the client was last contacted from a previous campaign. -1 means client was not previously contacted. Okay. That's actually a problem, because a lot of them were not contacted. And if we leave it as is, what's the best way to handle that? I think I know what I'm going to do. All right, I'm going to create a new variable called previously underscore contacted equals if else p days equals -1, then give it a 1, otherwise give it a 0. And then I will also do p days equals if else p days equals -1. So if it says -1, just treat it as missing, otherwise keep whatever value it is. Because I actually want to use this. Now we can do logistic overlay y tilde p days data equals d, except it's not liking, and then drop underscore na p days. Okay, so what is this saying? This is saying that as the number of days increases, the probability that they will say yes decreases, and that makes sense. Like, it's not fresh in their minds anymore. And there's quite a scatter, which you would expect, because like this line doesn't even reach the 50% threshold. So p days isn't that predictive. And so that's probably why you see a lot of scatter around it, at least relative to the other fitted lines, because there's a lot more uncertainty, because it's not very predictive. But I don't see anything wrong with that, so that's good. All right, cool. So let's go previous. What is previous? Number of contacts performed before this campaign and for this client. Okay, so I'm going to look at that one and make sure that doesn't have anything surprising. Previous, so how many times they've been contacted in the past. Okay, so there are zeros. So it's handling that in a sensical way. Wow, somebody was like 20? That's crazy. All right, this is going to be another one that's probably going to give us issues, because if I look at flexplot previous -1 data equals d, it's going to be super skewed. Yep, it is 0 inflated. I think that's probably going to have some issues when we visualize. Skewness alone isn't really a big problem. Like if you're thinking about linear models, if you have a skewed distribution, it's usually not a big deal. What is a big deal, though, is non-linearity. And unfortunately, those two kind of go hand in hand. That if you have a super skewed variable, very often you also have non-linearity. So I'm suspecting that this a similar thing's going to happen here. That as soon as I look at the logistic overlay, that we're going to see some non-linearity. So logistic overlay, and I'll go y tilde previous data equals d. All right, and this is actually a limitation of the plots. So there's only 2 data points. Why are there only 2 data points? Because there's not that many unique values to bin off of. Actually, if I go table d $previous, oh, okay, there's 25 unique values, and it's super skewed, and most of them are at 0. So most of these clients have never been contacted. So what do I want to do? I could do a log transformation, but 2 problems with that. One, you can't take the log of 0, which is fine, but you can take the log of the other values, and that will add some variability to it. Let me just try the simplest option. N bins equal, let's see, there's 25. Probably want 5 bins maybe. Let's try that. No. You know what I should do? Allow the user to specify the bins. So right now it's all done for you, and in a situation like this where it's kind of hard to figure out what the right bins are, that's going to be problematic. I suppose I could do it manually and use a magnet plot instead. That's actually a good idea. I think I'm going to do that. So I'm going to create a new variable called previous cat for categorical equals. Now you might be like, whoa, dude, I thought you were the one who said never to categorize a numeric variable. Yeah, I am, but I'm just doing it for the plots, see? Now let's see what happens. There we go. Okay, cool. I mean, it's not that different from the logistic overlay, because what I'm doing is I'm binning things, and then these would be the scatter plot dots, and then you can imagine the line going like that. Hey, that worked. Okay, cool. The whole point of me doing this is to see if what the model fits actually makes sense, and it seems like it does. It doesn't seem like there's some sort of strange bias like we had earlier. So that's cool. What haven't we looked at? Month. So this will be another example where magnet plot should come in handy. So I'll go y tilde month, data equals d. And we should probably create an ordered factor out of that too, because it's not going to keep the months in the right order. Although maybe I don't care. So the magnet plot defaults to sorting based on the logistic regression. So it's not like January, February, March, April. Instead, it's ordered by which months have the most success, which actually I'm okay with that. And that's kind of interesting. That's weird. So apparently they had like a big old campaign. So May and July. May, certainly. It's like double the sample size of July. So I don't know why May was such a popular month, and I don't know why October. Well, December, it looks like December is the word. Man, this is so helpful. This is such a good plot. Sorry, I just had to like stop mid-sentence to say this is extremely helpful. Interpreting what's going on. I love it. So, because I can immediately see from the plot, December has the smallest sample size. I don't even have to look at the numbers. I can just look at the dots. And so I can say, see, and that makes sense, you know, December is a holiday. In Brazil, I would assume they celebrate Christmas in Brazil. If you're Brazilian, let me know. And especially let me know if that was a really dumb question. But October is the month with the most sales. October, December, and March. And then there's a steep drop off. I wonder why those months in particular they have more success. You know, maybe you can say there's the holiday spirit, and maybe the fact that like school starts, but then you would expect to see something in September. But maybe like in September when school and I don't even know if they start at the same time. Yeah, this is all in Brazil. I'm not going to comment because I have no idea what's going on. What's the last variable? Let's look at housing. Has a housing loan. Okay, so that's another example where we can use magnet underscore plot. Y tilde housing, data equals D. And so more people have houses than do not. That's the first thing that pops out. And those who do not have houses are more likely, not by a lot. So we're talking like 15% versus like 10%. So it's not that big of a difference. But if you do not have housing, you are more likely to say yes to this campaign. So that's cool. So part of me wonders whether we ought to look at some of these things together. So magnet plot, at least right now, does not allow paneled plot, but logistic overlay does. So I'm going to start trying to visualize these together using logistic overlay plots, because I can visualize them together, whereas I can't with the magnet plots. So logistic overlay, and I'm going to go y tilde duration underscore log p outcome. Man, these are so cool. All right, and you know what I'm going to do? I know what I'm going to do. I'm going to put it on the logit scale, because it's hard to tell if they're interacting. And much easier to tell with that. And I'll do ghost.line equals red, so I can see better if they're interacting. So certainly some evidence of interactions, because those lines aren't parallel. So if I were to build a model from those two variables, I might say, yeah, let's add a interaction effect. But it looks like that seems to be fitting the data well. That seems to be fitting the data. That one's a little weird. I don't like how that looks. But everything else looks fine. Maybe I'm okay with that one not looking good. All right, I'm going to build a model from that now. Mod equals glm y tilde duration underscore log plus p outcome plus, I'm going to include the interaction between the two. And just do a model comparison. And why am I doing this? Just because the plot suggests that it might be an interaction, and part of me is just trying to test the plots and see if what I'm seeing is to be believed. So family equals binomial and reduced. So if I fit those and then do compare.fits. So this isn't one of the new plots, but I do want to see what things look like. So duration underscore log given p outcome, data equals d, and then full and reduced. See if this plot is beneficial, and it looks like it is going to be beneficial. So when I do these model comparison plots, now we don't have the binned data points, but that's okay. I've already looked at it in different ways. What I really want to see is, are they generating very different predictions? And at least for this one, absolutely they are. And so I think that seems to suggest that the interaction should be kept. Let's see what the model comparison says. It's really hard to tell with logistic regression sometimes. I mean, the plots can look vastly different, but then the model comparisons say, nah, they're not that different. Let's see what the model comparison says, though. Okay, so AIC is favoring the full, BIC is favoring the reduced, so is the base factor, p-value is favoring the full. So there's some disagreement, so it's a little ambiguous. But what I'm happy about is that kind of matches my visuals. So we started here, and I said, it looks like that could be an interaction. Notice I said it could be. I wasn't sure. And when I do a model comparison, the model comparison isn't sure either. So it's kind of validating that the plots are working. So that is cool. Now, I think this would be a good time to use the added variable plot. So I'm going to just go with a full model. P outcome is the variable. So let me see if I can do an added variable plot. I'm going to use it a different way than what I showed before, and I don't even know if it's going to work. So I'll go y tilde previous data equals d, lm formula is equal to y tilde, and then I'm just going to use this. I'm not going to go into too much detail, but normally when I've used added variable plot, I show like y tilde a plus b plus c plus d. And whichever variable is entered last, that's what goes on the x-axis, and then it fits a model between a, b, and c, computes the residuals, and then plots those residuals against whatever is left. But this time, I've got a more complicated, it's not just main effects, and so when that happens, at least with the regular added variable plot, you can use the LM formula to specify how those residuals are computed. I don't know if it actually works for logistic plots. Yeah, it does. Huh. Okay, cool. Okay, here's going to be a good test. This visual is telling me that once you control for duration and p outcome, there's essentially no relationship between previous and the outcome. So I'm going to see if the model agrees. This will be interesting. So I'll go full. I'm just going to copy this. I'm going to use the shortcut this time. So duration log times p outcome plus, now the new variable of interest is going to be previous. So that's the full, and this is the reduced. Duration, and then now I'm just going to get rid of previous. And if the added variable plot is working as I hope it works, this model comparison will say, yeah, you don't need to keep that variable. So if I do compare.fits, y tilde, I'm going to put the previous on the x-axis here. Given p outcome, I'm just going to get rid of duration log data equals d, and then full and reduced, because you don't have to include all the variables in compare fits. All right. Why am I smiling? I am smiling because regardless of whether it's the full or the reduced, those lines are flat. So this plot, which is not one of the new plots I invented, but still, this plot is showing that previous is not doing anything. Doesn't help us whatsoever, which is exactly what the added variable plot told us. Now if I do model.comparison, full and reduced, and back that visual up with some stats, So the AIC is favoring the reduced, BIC is favoring the reduced, base factor is, p-value is. Absolutely. Bam! Ha! The logistic added plot worked really well. And the magnet plots are working really well. And the logistic overlay plots are working really well. These are working really well. And what do I mean by working really well? They are giving me insights about how the data are behaving that are influencing my modeling decisions in such a way that I'm building better models. That's how you know you've got a good visual, is if they're telling you something about the data that changes the way that you build models. And that's absolutely happening here. So these are really good plots. So my conclusions from this. These tools work really, really well. Like, I am very pleased with the magnet plot. Like, it makes it so intuitive to interpret categorical on binary predictions. And the logistic overlay is doing a great job. I mean, it helped me figure out, oh, this variable is really messed up. And like I said, like, the whole point of the plots for me is to guide you in choosing a model. And that's exactly what it did. It guided me in choosing an appropriate model. And that's fantastic. I am thrilled with how it's worked out. So hopefully you've enjoyed that. And by the way, starting in August, I'm going to have an office hours class. It's the first one I've had for a while. And how that works is you come in with your questions and we spend the entire time answering your questions. It's going to be awesome. So it's kind of like doing consultations, but you do it with a bunch of other students and you get to learn from their questions and they get to learn from your questions. So hopefully I'll see you there. And as always, you could always take a self-guided class if you so choose. Anyway, this has been so much fun. I hope you have had fun too. I'll see you next time. Peace out. You want to know the most popular plot in all of plotindom, in all of sciencedom? A bar chart. They're meant for counts. Like, you don't represent means as bars. The differences would become minuscule, tiny, whatever. Why? Something's wrong with your paper, and almost inevitably they have somebody who has no idea what they're doing. Everything. Everything. Yeah, but it's the best we've got. Whatever. Who cares if it's the best we got? We got to do better, man. It's not the best we've got. All right? You just not compute power. That's an idea. Ha! So take it anyway. Ha! What's the worst that could happen? You learn. Oh no. I'm just here having fun. You're putting so much weight on it. Just have fun, man. Have fun.